Hello, my name is Ethan Martin, and I'll be presenting to you my dissertation project on reducing the University of Waikato's carbon emissions. My supervisor for this project was Martin Atkins. As you see, this is my poster that would have been presented at the Engineering Design Show, and I will be going through it today as well as a few more aspects of my project. So with the recent government initiative to have the public sector of New Zealand carbon neutral by 2025, this gives the university a very short time to act on its current fossil fuel usage. Currently, the university uses natural gas to fuel around 50 boilers around the Hamilton campus to provide space heating. It also has a fleet of vehicles that range in fuel types, and it uses electricity to power the general day-to-day activities. In 2020, the combined carbon emissions of the university comprised of 550 tonnes of CO2 equivalent emissions from the use of natural gas, and around 200 tonnes from its fleet, and around a kilotonne of CO2 from its electricity. The consumption of electricity was significantly higher, thus the higher emissions. So this is obviously no small task. So an appropriate scope was decided by myself, my supervisor Martin, and with the help of the property services team at the uni. We decided upon two parts. The first being a complete electrification scenario of the university energy, which includes analysing the current usage and comparing it with a future electric alternative system, and to calculate potential energy, cost, and carbon emission savings. The second part includes a detailed design for the replacement boiler system to replace the system currently in the K block building. This will include a design process where different carbon neutral options are analysed to replace the system. A complete electrification of the university energy would see no more fossil fuel burnt on campus, with the only emissions coming from inherent emissions from generating the grid electricity we use, which is much less per unit energy than fossil fuels, and will get better and better as we reach a greater percentage of renewable electricity generation. So I have there the current annual demand, which is comprised of electricity, natural gas, and quite a bit of petrol and diesel. This combines to being 47,000 gigajoules per year, resulting in 1,650 tonnes of CO2 equivalent per year. So I found some possible reductions to this. So for electricity, improving building utilization, specifically HVAC and lighting efficiencies, can reduce the total demand by 10%. Gas, in terms of space heating, can find a 73% reduction in demand and an 84% reduction in emissions by replacing the natural gas boilers with heat pumps. Switching to electric vehicles will see an 85% reduction in emissions as well. This is a total of 16% reduction in the total energy required at the uni, as well as a 41% reduction in carbon emissions, saving 800 tonnes of CO2 every year, with emissions, as I said, being only from the grid electricity we use, but that will decrease. A potential solar panel outlook was also investigated, which isn't very efficient, but an ideal situation would see a further 6% reduction in carbon emissions. For the K-block design, K-block was chosen because it uses the fourth most natural gas at the campus, as well as being very similar to F-block, so a similar system could be used for that building as well. The system uses 3 biomass wood pellet boilers to replace the current system to provide an elegant and complete system. This was reached by considering electrode boilers, heat pumps, and biomass systems with various calculations and energy analysis. With a fully implemented control system, the 3 boilers can be self-controlled to input pellets to meet demand and can be changed as required by the operator. The current piping and air handling unit system in the building is appropriate for this new system, which is quite important. The system would reduce the carbon emissions of the building by 98%, saving 70 tonnes of CO2 every year. I also made a 3D model to help with the designing and iterative aspects of the design, and so we can see that there is a pallet system that conveys the pallets up to the top as required, and then this inlet hopper would be underground to, it's easy to be underground. And then for the plant room, the 3 boilers are spaced a little bit differently to how the current boilers are, but the air handling units and the current piping would be pretty satisfactory and not many changes would have to be made. So thank you very much.